Alright, so welcome to day 19 now. So we have our notebook ready and we are connected as well. So today is more like a surprise day. I mean, not too many surprises, of course. So it's about solving problems, right? So whatever we've learned, right, it's very important to keep applying them in real life, right, and test our abilities of how good we are able to solve these problems. Now, today, like in this week, we've covered about dictionaries. So today we are going to test our skills of how to use dictionaries in practical life, right? To solve problems. Now we'll look at couple of problems. So I'll type in the first problem right here. So let's open a text cell and let's push it upwards. And yes, so let's type. So question goes something like this. Okay, I'll keep it in heading 1. So question is, yes, I'm putting Q1 here. Let's say we have a list L1 equals to 1, 2, 2, 3, 2, 3, 4, 5. Okay, so we have a list. Now the question is, now identify the most repetitive element in the list. Okay, so this is our question right in front of us. Okay, now I want you all to pause the video at least for 30 seconds and I want you to think about how would you solve this type of a problem, right? The hint here is to use dictionaries. Of course, there are multiple ways of solving any problem, but because we've learned about dictionaries, I want you to think of how can you use dictionaries in this case. Okay, pause the video right now and start thinking about the problem. Okay, so I hope you paused it and now we are back. So how can we use dictionaries here, right? Now, if you understand the question properly, the solution automatically comes as you think, right? Now, what does it say? It has elements 1, 2, 2, 3, 2, 3, 4, 5, right? Now identify the most repetitive element in the list. Now let's not even try to code anything, right? So first let us try to solve the problem just by looking at this. Okay, simple. Now how many ones are there? Only one is there. I'll just zoom it for you, right? How many ones are there? Only one. How many twos are there? So I'll put ones. Number of ones is 1. Number of twos. So let's count the number of twos. So there's one here, and one here. Right? So there are 3 twos. Then threes. Let's look at number of threes. 1 and 2. Okay, there are 2 threes. Then fours. How many fours are there? There's only 1 4. And fives, finally, there's only 1 5. So what we see is, without even coding anything, what is the solution? 2 is the solution because that is the most repetitive element, right? Now we need to exactly do this in terms of coding as well, right? Now let's see how you can use dictionaries and solve this problem in seconds. Okay, now you just have to create a dictionary. So let's say we create a dictionary called number counter, right? So num counter is an empty dictionary. Okay, now actually my auto code is already giving the answer, but let's not accept it. So let us write our own code, right? So for I in the entire list L1, okay, so let's not use that code. So let's try to write our own, right? Now for I in L1, right, what do I have to see? My number counter is empty. Ideally, my final answer should look like the key should be 1 and number of times 1 is repeated. the key should be 2 and number of 2's are there, and 3 number of 3's are there, right? So and so on for any other values. So how do you come up with that? So simple way is, so in dictionary you can check. Now for example, we have this num counter is empty dictionary, isn't it? Now you can check if 1 in num counter, right? So if 1 in num counter, so let's say print 1 is present, else what do you say? Let us add 1 into this num counter of 1 is equals to 1. So let's run this. Okay, so it didn't print and instead it added to this num counter. Okay, so it added this, you see. So we can actually do a check every time. You can check whether an element is, so let's run this again and see. Now this time it says 1 is already present, so don't try to add anything, right? So this is the logic, right? So the logic that we are using is, if that element is in this dictionary, you do a check. If it's not, you add it, right? And that is the concept that I'll be using here. So you see for I in L1, right? So that means all the elements in L1. Now what is L1? We have not defined L1. So let's define L1. So L1 is equals to R1, 2, 3 and so on. 3, 2, 3, 4 and 5, right? So we have our L1. So if I in your num counter, if it's already there, you just add one more, right? I'm typing the exact one as well, right? So plus or equals to 1. So if it's not there, you have to assign a single value for this num counter, right? Now let us run this code. Okay, we can delete our below code. I was just using it to explain. Now let's get back and now let's look at our num counter, right? Now as you see, we have ones is only 1, twos only 3 twos, yeah, we've got it perfect. Threes, number of threes are 2 and fours is 1 and fives we have only 1 5, right? Now are we already done with the problem? No, right? So we only solved it to 90% we are there, right? But we still have to identify which is the highest, right? Now how do we identify the highest? Very simple. You go through every single key value pair, right? Now whichever value, so what is key? Key is the first element, right? So which is on the left hand side of this column is the key, right hand side of the column is the value, right? Now every time you have to look at this value and see whichever is the highest value. Okay, so that's all you have to do. So let's see, for key comma value in num counter dot items. Remember, how many of you remember this one, right? So we used items, right? Now what we can do is, let's say we declare a minimum value of 0. Okay, so we declare a minimum value of 0. Now if any value is greater than this 0, okay, so if any value is greater than this temp, what do we do? So temp is equals to this value, and then temp is equals to this value. My final result, right? So the result that we are looking for is the key every time. Like so okay, let me explain, right? So what am I doing? So for key comma value, meaning key is 1, value is also 1, key is 2, value is also 3, right? So every time you iterate between key comma value in whole dictionary. Now for first one, so it checks what is v, 1, temp is 0. Okay, so 1 is greater than 0, so it goes into it. So now temp is updated to 1, right? And my final result is updated to 1. Then it gets to this 2 comma 3, right? So then it identifies, okay, so 3, right? So 3 is greater than the previous temp was 1. So it keeps on updating. So for more clarity, what I can do is every time I can print this, print what is k value. So I can use my f strings. So print k value. You can print v value, and you can also print temp value as well. So for yourself, how these are all changing, and final result, we haven't given any final result, so we have to declare that variable. So let's keep it none, and now run this. You see, so all the iterations, so it went through 1 2 3 4 5, yes, keys, values, and the temp, how it got updated each and every single time. Now final result is final result is 2. So as you see, so we went through it, right? So this is how you can solve problems, right? So yes, I hope you liked it, right? So I'll give you second problem as a part of this weekly project, right? So that should be quite fun. So I'll see you in the next module.